Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 4.4, Understanding and Calculating Slope. So we've been calling slope all along the changer. So today we're going to give it its real name. All right, so number one, the warm-up here. Remember, it doesn't do you any good to just copy the answers for the warm-up, so you really want to try it yourself first. All right, let's see. So we have to find our starting value, which is when x is 0. What is y? So this is going backwards by 10. So if I back up from 10 spots, I get -2. Okay, remember the starting value is really just the y-intercept. It's what is the value of y when x is 0, which puts the point on the y-axis. All right, and then we're calculating our changer here. This goes up by 10. This goes up by 1. So the change here is going to be 10 divided by 1 for 10. So my formula will be y equals 10x minus 2. Okay. Number 2, our y-intercept or our starting value is already given to us. It's what's the value of y when x is 0. That's the place on the y-axis. And then our changer this time, let's see, is going up by 6, up by 2. So our formula is going to be 6 divided by 2, which is 3, times x plus 15. Okay. Number 3, we have our starting place on their table already given to us. So what's the value of y when x is 0? That's going to be 7. So there's our starter or our y-intercept. And the changer here, let's use these two. This is going up by 9 and up by 3 on this side. So it's going to be y equals 3x plus 7. 9 divided by 3 will make this one. Okay. All right. Calculate the x and y intercepts and then graph the linear function 10x minus 5y equals 30 by using only the intercepts that we calculate. So our first intercept we're going to find is the x-intercept. Okay, remember we get the x-intercept by calculating for x when y is 0. Okay, so I've got 10x equals 30 and x is 3. So my x-intercept goes right there. All right, and then we're going to calculate the y-intercept. Okay, the y-intercept is calculate for y when x is 0. So 5y equals 30. Then the 10 times 0 goes away. And we find out that y is -6. So 1, 2, 3, 4, 5, and -6 is right there. Okay? And then we graph our line through these 2 points. So we get 10x minus 5y equals 30. Okay, and that's our line. So remember, the x-intercept is the place where our line crosses the x-axis. So this is really the coordinate 3, 0. Don't get fooled into thinking you can always just write 3. Sometimes you need to look for an ordered pair there. And the y-intercept is a place where the line crosses the y-axis. So that means the x is 0 and the y is -6. So all points on the y-axis have 0 in their first spot, and all points on the x-axis have 0 in their second spot. All right, on to page 2. All right, page 2. We're talking about slope here. So the definition for slope is the slope of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. So a ratio, remember, is just 2 numbers compared by division. So the up and down divided by the left and right between any 2 points on a line. So what slope really does is explains the steepness of the line. Okay? So it gives you a number. You say, oh, the slope of that line's 12, and everybody should be able to tell exactly how steep that line is just by knowing that number 12, or 1/2, or -7, or 0, or whatever the number is. Okay? So at the end of the day, in the end of class next time, if I said, oh, that slope has a steepness of 1/2, you should be able to draw a picture of how steep that line is without knowing anything else. Okay? All right, so calculating slope. The slope of a non-vertical line passing through 2 points, x1 and y1. This is just point 1. That's what those little ones underneath there mean. And x2, y2. This is just point 2. Okay, that's what those 2 little 2's under there mean. Is the ratio of the rise, the change in the y, to the run, the change in the x. Okay. So slope equals rise over run. And the change in the y is the top, the change in the x is the bottom, and we can do it by just subtracting the two y's and subtracting the two x's and then dividing them. Now we've actually been doing this all along, and I'll show you what I mean in just a second. Okay, so find the slope of a line that passes through these 2 points. So this just says, hey, look at the y coordinates. Our y coordinates are 2 and -1. And do subtraction with them. So the change of them means a subtraction. So -1 minus 2. It changed from -1 to 2. How much was that difference? Okay. And then we look at the x coordinates, 5 and 4. So we do the change in the x's, 4 minus 5. Okay. When we do this division, we are going to end up with -3 over -1, which is +3. So the steepness of this line is +3. That means, given 1 point, I can get to the next point by going up 3 and over 1. And that's what my line would look like. Okay, so everybody should be able to draw that. Oh, steepness of 3, that's 3 over 1, so the up is 3 and the right is 1. Okay, all right, number 3, same thing. So we're going to find our steepness here. So we do the change in the y's, 6 minus 3, over the change in the x's, which is 4 minus -2. So give me 3 over 6, which reduces to 1/2. Okay. So if I asked you, hey, can you tell me how steep that line is? In the picture of this would look like this. Here's 1 point on the line. If I went up 1 and over 2, I would find another point on the line. So I could tell exactly how steep it is. 3 is a bigger number than 1/2, so 3's line is steeper than 1/2's line. Okay. Now, the other thing, both of these numbers are positive. And that's because if we were a little man walking from the left side of the line to the right side of the line, we would have to go uphill on both of these points. Okay. So walking uphill gives you a positive slope. We read from the left side to the right side, and we do math from left to right. So the reason why it's positive is because we're walking uphill left to right. If you look at number 4, if I'm a little man on this line and I'm walking, I am walking from the left side to the right side. I am going downhill. So that's why we're going to end up with a negative number when we calculate this slope. All right, so the first point here is 4, 2. And the second point is up here at 2, 8. And then we do our slope here. It's the change in the y's over the change in the x's, 2 minus 4. So 8 minus 2 gives me 6. 2 minus 4 is -2. So this will give me -3 for the slope. Okay. So if I was to draw a picture of this, which is already here, then it means to get from 1 point to a new one, I could count down 3. There's 3 and go over 1, and I'd get to the next point. Or if on that point, I could count down 3 and go over 1 again. So this tells me about the steepness of the line. Now, like I said, I told you we've been doing this all along. So let's say we have a table, x, y, and we want to find the changer amount. Well, our 2 points in here are 4, 2 and 2, 8. Okay, we find the difference. Oh, this goes up 6. This goes down 2. And then we would say our formula, y equals -3x plus something we don't know yet. Okay? The changer value that we've been calculating all along is just the easier word than slope to understand. So slope is the change in the y's divided by the change in the x's. Well, here's our change in y's, here's our change in x's. We divide them and we got -3 for the ratio. Okay? Okay, on page 3, we have number 5. Find the slope of the horizontal line y equals 4. So if I asked you to tell me a value for how steep this line is, this line that goes straight from left to right, like the horizon, hopefully you would tell me this answer. It's not steep at all. It either goes uphill or downhill, so it would be 0. So let's calculate it and see if we get the same thing. So this point is 2, 4. And this point right here is 6, 4. If I calculate the slope between them, I do 4 minus 4 on top and 6 minus 2 on the bottom. 4 minus 4 gives me 0. 6 minus 2 gives me 4. I divide that and I get 0. Okay, so my slope is 0. And that's because a horizontal line has no steepness. It neither goes uphill or downhill. All right, number 6, find the slope of a vertical line, x equal to 4. So we have 2 points here, 4, 4, and 4, 7. So we'll find our slope. On the top, we could do 7 minus 4. And on the bottom, we would do 4 minus 4. This will give us 3 over 0. And if we try to type this on the calculator, we're going to get an error message. Okay, a divide by 0 error message. And that's because you cannot divide by 0 into something. No matter what you multiply 0 by, it'll never become 3. So our slope here is a special word. We're going to call this slope undefined. That means it is so steep, I can't give it a value. Okay? If we look back at our definition of slope from the previous page, notice it says the slope of a non-vertical line is the ratio of the vertical change divided by the horizontal change. Well, in this problem, we did not have a non-vertical line. We had a vertical line. So the slope is undefined. There is no slope for that. Okay? All right, at this point, I'd like for you to pause the video, try 3 of these problems, and see if you can come up with what the slopes are for all 3. And then come back and check over it. Okay, welcome back. Our first one, we should be doing something like this. Negative 2 minus 2, that's the top. And on the bottom, 5 minus 5. So the negative 2 and 2 are the change between the y's, and the 5 minus 5 were the change between the x's. And when I do this work, I get negative 4 over 0, which, that doesn't work. So we write undefined. If we were to graph these and connect them, they would make a line that is straight up and down, or a vertical line. Okay. Number 8, do our slope here. So this is 4 minus 4 on the top. That's the change in the y's. And on the bottom, we do the change in the x's. So the rise over the run. X's are the run left and right. So this is negative 3 minus 0, which gives me 0 over negative 3, which is 0. Okay, so here's my slope. What would this line look like? Well, if I plotted it, this should be a horizontal line. And remember, in number 7, this should be a vertical line. Okay, 0, 6, and 5, negative 4. So my slope would be negative 4 minus 6 over top of 5 minus 0. So give me negative 10 over 5, which is negative 2. So the steepness value for this line is negative 2. That means it should be going downhill from left to right. So if I plotted a point, I would go down 2 and right 1 to get to a new point. And that means my little guy here is walking downhill from left to right. All right? All right, so on our last page here, we have rate of change definition. So rate of change is just a fancy way of saying real life slope. Okay, so it's still comparing 2 things with division, 2 changes with division, except we're using like real life stuff. So it's just a fancy way of saying slope. So a rate of change compares a change in one quantity to a change in another quantity, just like slope, the change in the y to the change in the x. For example, if you are paid $60 for working 5 hours, then your hourly wage would be $12 per an hour. So we had 60 to 5 as 1 point, okay? So 5 hours makes $60. And we also know if we work 0 hours, we would get $0. So then we could do 60 minus 0 over 5 minus 0, which would give us 60 over 5, or $12 per 1 hour. Okay, so our rate of change describes the pay, how the pay increases with respect to time. So you get $12 extra every hour you work. Okay, now this table in number 10 shows the cost to paint a house for a given number of hours. Find the rate of change and cost with respect to time. So we have these inputs. These are the inputs. This is like our x, but it's time. And we have these outputs. This is like our y, but it's cost. So we could pick any 2 of them. I'm going to go up these 2. So I could do the change in the outputs, 180 minus 135, over the change of the inputs, 8 minus 6. So this would give me 180 minus 35 is 45. And 8 minus 6 is 2. And if I divide that, I get 22.5. That's our rate of change. So what does that mean in real life? Well, it cost $22.50 per 1 hour. All right. Slope and rate of change. So you can interpret the slope of a line as a rate of change, okay, when you give graphs of real world data. So remember, slope is real life, rate of change is real life slope. So given like this graph of this real life stuff, we could then just look at the slope and compare our rates of change. So number 11 says, describe the rates of change in the attendance with respect to time for a movie at the local theater. So this is week 1, okay? And at week 1, we have, let's see, that's 100, 200, 300, 400, 500, 100 people. So from week 1, we started with input 1 gave us 100 people. And at input 3, the third week, we got 300 people. So we could calculate our rate of change here. So 300 minus 100, 3 minus 1 gives me 200 over 2, which is 100. Okay, so our rate of change here is 100 people per week. So it's going up 100 people every week. All right. Weeks 3 to 7, that's here, and ends over here. So at week 3, we had 3 and 300. And at week 7, let's see, so 7 gave me 250. So we do our rate of change. So our slope here is 250 minus 300 over 7 minus 4. So 250 minus 300 would be negative 50. 7 minus 4 is 3. So if I divide 50 by 3, we get negative 16.6 with a bar. So that means we are losing 16.6 people per week. Okay, so at first there wasn't many people attending the movie, but then our rate of change increased, so we get lots of people, so it's growing quickly. And now from weeks 3 to 7, it's going down slowly, so less people are coming. And then from week 7 to 8, we go from the 7 and 250, and we end up at week 8 having only 50 people come. So our rate of change would be 50 minus 250 over 8 minus 7, which will give us negative 200 over 1, which means we're losing 200 people per week. And that's probably why they stopped showing the movie after week 8. Okay, so we increased attendance, and then it slowly fell for a while, and then it completely topped off. Okay. All right, so your follow-up tonight is the Khan Academy recommendation about slope from 2 solutions. Okay, so you're given 2 ordered pairs and you calculate the slope. So just like what we were doing back here on page 2 at the bottom and on page 3 at the bottom. Okay, I will see you in class next time.